Okay, hello everyone. Today we will continue with chapter number 2, part 1. This chapter will be covering phasor and also power related to electrical machine. Okay, so we will start with phasor. So what is phasor? It is actually a sinusoidal voltage or current at constant frequency, which is characterized by two parameters, which is the maximum value, or we call it as an amplitude, and also a phase angle. Okay, so phasor will have a phase angle and also a maximum value. So you can see the example here. So this is for voltage. So voltage at time t equals to V maximum. V maximum is the maximum value of the amplitude, and we have a cos omega t plus. This is the phase angle. Okay, so a voltage has a maximum value V max and phase angle. So this we call it as a delta when referred to cos omega t. Okay, so this is example for a phasor. Okay, so there's another term called the root mean square value, or we call it as a RMS value. Okay, RMS stands for root mean square. We also call it as a effective value. Okay, so usually electricity, when we are dealing with electrical machine, so it will have a maximum value as well as the effective value. Effective value is always referring to the nominal value, or at which voltage or current the machine function. So the RMS value is very important. Okay, for a sinusoidal voltage or the fluctuating voltage, so how we can calculate the root mean square? So VRMS, okay, VRMS it's actually V max divided by square root of 2. Okay, so this is the formula to calculate VRMS. Okay, so we also can have the representation using a Euler identity. So as we can see here, so it can be a combination of cos and sine. Okay, and also in this form, exponential form. Okay, so all this can be representing a voltage or current in an electrical machine. Okay, so we can see here for voltage V T, T is time. Okay, so VT we can represent as RE stands for real part of. Okay, we can divide, so whatever expression we can divide into two, real part and also imaginary part. Okay, for voltage, we can calculate the real part using this formula V max exponential to power of j omega t plus angle phasor. Okay, so and it is also the same. Uh, we can get from this formula, so we can get this. So V max is actually V times with square root of 2. So that's why we get it like this and exponential. So we can expand it. Okay, and j is actually square root of negative 1. If we want to calculate in a value, so we can replace it inside to calculate the value. So as I say earlier, RE representing the real part of. Okay, so we can see here another thing, the RMS phasor representation of the voltage is given in three form: exponential, polar, or rectangular. Okay, so we can represent this RMS phasors. Okay, phasors are related to angle, so we can represent it in the three form. Okay, three form usually. So it can be either exponential, so like this, or it can be in a polar form. So you can see there's an angle here, or it can be a rectangular. Rectangular will involve two part cos and also sine. Okay, so we call it as a rectangular. So a phasor can be easily converted from one form to another. Okay, so exponential can be converted to polar, polar can be converted to exponential, exponential can be converted to rectangle, and so on. Okay, so conversion of polar to rectangular is shown in the phasor diagram. So usually we will convert polar to rectangular. Okay, but it can we can do it vice versa. So how we want to find? So we can use this phasor diagram. Okay, this phasor diagram is used for converting from polar to rectangular form. So this polar diagram, phasor diagram, we can see. So it has a imaginary axis and also real axis. So we can have. So let's say this is V. So it will be represented by the cos component and also sine component. A sine component, we can see there's a j because there's a value in the imaginary axis. Okay, so this is a simple mathematics. So Euler identity can be used to convert from exponential to rectangular. So we can use few things because earlier we have seen. So it has three, so it can be converted from one form to another. Okay, so the relationship between the voltage and current phases for the three passive element. Okay, so in electrical, so there are three things that we always will play around. So the first thing is the resistor, the resistance value. Then we will have an inductor, which is using a inductance, and also capacitor, which gives us the capacitance. So this is the symbol for resistor. So this is the symbol for inductor, and this is the symbol for capacitor. Okay, so we can see these three symbols usually in our electrical circuit. Okay, so when we want to convert or relating voltage and current phases, uh, we can do it using these formulas. Okay, so we can see the summary here. So sinusoidal steady state excitation and also constant value of R, L, and C are assumed. So usually some of the values will be given, then we need to use these formulas to calculate. So we can see this is a linear. When it involves resistance, it will be a bit direct because we are familiar with this formula V equals to IR. But when we have inductance and also capacitance, we need to use this part, which involves J. So when J is involved, it will automatically become a imaginary part. Okay, so we will see it later. So when voltages and currents are discussed in this chapter, so lowercase letters such as V, so small v in bracket T and I T indicate instantaneous value. So instantaneous value meaning current at, so let's say for example current at 5 seconds. So T is 5. So that is the instantaneous value. So meaning we will have equation. We just need to calculate for time t, time t equals to 5. So we replace 5 inside the formula. So then we can get the instantaneous value. And uppercase letters like V, capital V, and I indicate RMS values. Okay, earlier we have seen what is RMS value. And uppercase letter in italics. Okay, so like this, V italic and I italic indicates RMS phases. Okay, so when voltage and current values are specified, they shall be RMS value unless otherwise indicated. So usually we will give it in a RMS value. So if not, we will be telling. So we'll see a few examples for you to understand. Okay, so it's actually pretty easy if you understand the concept. Okay, so for here we can see in this example the current IT. So this is the formula given. So IT equals to 100 cos omega t plus 45 degrees ampere. Okay, so from here we can see. So the question asks us to find I maximum and I RMS phasor and rectangular representation. So we'll see how to solve it. Okay, so this is the solution I have draft for you. So the maximum value, the question earlier asked to find the maximum I. So the maximum value of I max equals to 100 ampere. So we can get it directly from the equation. Okay, so it's given here 100. So I max is 100. Okay, no need to have any calculation. You just need to know how to compare. Okay, then we find the RMS value. So IRMS equals to 100 divided by square root of 2. Okay, where you got this formula? So we get it from here. So VRMS equals to Vmax over square root of 2. Okay, so here Imax is 100 divided by square root of 2. So we get 70.7 ampere. Okay, from the equation, we know phase angle is 45. So this is the phase angle. So phase angle is 45. So how we can represent the phasor, current phasor representation in polar form? So we just write it like this. So I italic equals to, so I RMS, so 70.7. So angle 45. So angle we no need to change. Okay, so this is the formula. I equals to I RMS times with angle. Okay, so angle we no need to calculate. Okay, so let's say we want to represent it in a rectangular form. The rectangular form we have seen earlier. So rectangular form will have cos and also sine component. Okay, so how we can represent it? Okay, so this is the simple way. So a phasor representation in rectangular form. So I equals to, so how we can find? So it has a two part. Okay, one is the real part and one more is imaginary part. So imaginary part usually will have j, okay, attached to it. Okay, so first we calculate the real part. So how to calculate the real part? So we know here we want to convert from this to this. So this is the IRMS is 70.7 times with cos 45. Okay, so this is based on page number 5. We go back to page number 5, so we can see here. From here we can calculate, so we can find out. Okay, so real part, so 70.7 times cos 45 degrees. So you will get the value of 50. So this is the 50, the value. And for imaginary part, so we know here, so the angle is 45. Okay, so the formula to calculate the imaginary part, so we take IRMS 70.7 times with sine 45. Okay, earlier cos 45, here sine 45. So we still get 50. Okay, so from here we can convert it to a phasor representation in rectangular form, which is I equals to 50 plus j 50 ampere. Okay, so this is a simple question. So easily you can get like 4 to 5 marks in the exam. Okay, so try to understand a bit direct, a bit easy for you to understand. So if you know how to do, so it will be much better for you. Okay, so we'll see another example. Okay, so earlier for current, this is for voltage. The voltage VT, okay, so equation is given. VT equals to 169.7 cos omega t plus 60. So if you're already familiar with this, we know. So this is the maximum value, okay, V max, and this is the angle 60. So we can compare with the standard equation. So we know this is V max and this is the angle 60. So the question asks to find determine RMS phasor. So you need to find the value. So representation in polar form. So we want to find it in a polar form. So polar form is like this. So we are asked to find it. So polar form is actually a bit easier than the rectangular form. The rectangular form you need to use this calculation. Polar form is a bit direct. Okay, so we will see how. So the solution is only 4 lines. Okay, you can easily get 4 to 5 marks. Okay, from this. So maximum value Vmax is 169.7. So we get it direct from the equation. Okay, so from this equation, then RMS value Vrms is similar like earlier 169.7 divide by square root of 2. So you get 120 volt. Or you can have it in decimal. Okay, so if decimal, I think 119 point something. Okay, so but we try to round it up, so we made it 120. Okay, so the unit is voltage because this is actually a voltage. Okay, so from the equation we know the phase angle is 60 because it's given here angle is 60. So a phasor representation in polar form, so V equals to so Vrms, okay, Vrms is 120. So angle 60. We don't need to change anything. We don't need to calculate anything. Okay, so we already found it in a polar form. So try to find in rectangle form. So try to find by your own how to find it. So you can use this. So you can convert it to rectangle form. Even though the question here is not asking you, but for your exercise, for your understanding, you can try to convert it. Okay, so there's two example for you to understand. So we move now to instantaneous power. So earlier we have seen instantaneous current, instantaneous voltage. So there is another thing called instantaneous power. Okay, so what is instantaneous power? So the instantaneous power supplied to a device is simply the product of the instantaneous voltage across the terminal times with instantaneous current. Because we know this is the standard equation for power. So power P equals to VI, so voltage times current. Okay, so my teacher always teach power P equals to VI, very important. We need power for everything. The political power, we need superpower. So power is very important. So for you to easily remember, I learned this 20 years back, so I'm teaching you also. So formula for P equals to VI. Power is very important. So P equals to VI. So similarly, earlier we have seen what is instantaneous voltage. We have seen what is instantaneous current. So instantaneous power is actually product of these two, instantaneous voltage and instantaneous current. Okay, so the instantaneous power is always expressed in watt. Okay, so power, the unit is watt. Irrespective to the type of circuit used, it may be positive or negative. So power can be positive or negative. Okay, if the value of power is positive, meaning the device is getting so power flow into the device. So the keyword is into. So meaning the device is getting new power flow inside. Uh, so like how when you eat, okay, when you eat a food, so the food is giving you energy, meaning the food is entering you and it give energy. So similar. So positive value when the power is into the machine. So we are learning about the devices and machine. So the power is going inside, then the value will be positive. So it will be negative when power is going out of the device. Work is done. So when we eat, we get energy. When we do workout, we lose energy. So our power is negative, so it's going out. Okay. So that's another term called complex power. So what is complex power? So complex power is defined as okay, power. The symbol is S, no more P. Okay, so it's a combination of real part. Okay, so real part of power plus with imaginary part. So that's why we have this J. So when you always need to remember when we have J, it is actually a imaginary part. Okay, so complex power is a combination of real part and also imaginary part. Okay, real part, you will calculate it based on watt, and The imaginary part, we will calculate it based on VAR. Okay, so not the VAR in the football. Okay, VAR is actually volt ampere reactive. Okay, and the unit for S is VA. Okay, so volt ampere, no reactive at the back. Okay, so this is the formula for complex power. So if the question asks you to calculate the complex power, so you need to use this formula. You cannot only calculate the real part or only the imaginary part. You need to calculate both. Okay, so we have a few types of power. So we have active power. Okay, so active power we can see the what is active power? The power wave consists of a series of positive pulses that vary from zero to maximum. So you start from zero, it goes to the maximum. You come down, go to maximum. It's not going down. It's not going negative. So that is what we call as a active power. Okay, the power transform from generator to load. So power is generated by the generator and it flows to the load. Load is a generator will produce. Uh, Load will uh, dismiss the power from the system. So this is to generate. This is to take out the power. Okay, so usually it will be balanced. Okay, so what we need to understand for active power, it always start from zero, go to maximum, come back to zero, go to maximum. It will never be negative. Okay, that is active power. Okay, so reactive power. So the positive wave correspond to the power delivered by the generator to the reactor. So we have the same setup. Just here earlier is a resistor. If we easier for us to understand, if the circuit is only having a resistor, we don't have an inductor or capacitor, it will be active power. Because the wave will be always positive or zero. It will never be negative. But for reactive power, we can see here it is having an inductance. So when it is having an inductance, so it will have both component. So it will have negative, it will have positive. So it will be more like a sine wave. Okay, so we can see when the value is positive, so meaning is above this line. Uh, so this is called positive on top. So generator, the power is delivered from the generator to the reactor, meaning it's going from here to here. A negative value when it moves from here to here, so inductor to the power, so reactor to the generator, it will become negative. So meaning the power will go from here to here positive, and from here to here negative. So that is what we call it as a reactive power. Okay, so we have seen on the power and we have seen on the phasor. Okay, so very short lecture. Okay, so try it yourself. So some of the exam questions for you to try. So we have given some questions here. So peak voltage is actually the maximum voltage. So peak current is maximum current. So try to find from whatever information here. I also have given you the answers. So try to compare and learn how to do it because this kind of questions will come out in the exam. Okay, so I think that's all from me. So thank you so much.